The predictive analytics is the process of analyzing the data, the past and the present values that are connected through the big data collection techniques, bounding the values between 0 and 1. We get the following logistic model. We use the logistic model here. Remove the values that are even critical but are not included because of the OLS. Hello students, welcome to the next session of Cloud Computing and Big Data Analytics. I am Dr. Soumeshri from Department of Computer Science, Vidhyaashram, First Grade College. Let's start this session. This session is all about learning another concept known as the predictive analytics. What is this predictive analytics? What are you going to do in this predictive analytics? Let's know this. Okay. The predictive analytics is the process of analyzing the data. As it says, it is analytics, analyzing, okay, or the algorithms or the procedures which helps in analysis of the data. What kind of data you are analyzing? What the meaning of the term predictive? We use the current and the historical data or previous data, past data to predict the future of the data. That is, if you have collected a data and has stored in the database or some data storing techniques, then you have current data as well as the historical data, isn't it? Or the past data that is already stored. You will use these data that are stored for predicting the future outcomes of the data. How they can be used, that same data, and what may be the prediction you can make, what may be the possible outcome when you use in the future, or if you use some other day, not today, some other day when you use, what may be the outcome. Predicting these outcomes by using the statistical methods. There will be so many statistical methods, the statistical algorithms, machine learning algorithms, they all combine together to predict the future outcome of a current and historical data, which is called as the predictive analytics. Okay. So how do you do the predictive analytics is, one is do through statistical techniques, another is through the regression models. What are these regression models? Okay. So regression model is a technique for predicting the continuous values. You have to predict the continuous values based on certain inputs or variables. Based on the inputs, that is the historical data or the input variables, you are going to predict the continuous values, predict the future values that can come from the stored data. Like we have stored the search history of a customer. You can, in future, you can make the future outcomes or future predictions. Suppose if the customer is looking at the baby products, you may have the prediction of he may need the clothing and the facilities and the sports equipments for a toddler, isn't it? Once the baby is there, it will grow up definitely, isn't it? So he will need grown-up clothes, so many toys and other equipments. So prediction is predicting based on the current input or past input. Regression is a technique for predicting the continuous values. You have to predict the continuous values based on the past and the present data. Okay. In regression, we have two types of regression. That is, one is the linear regression, another one is the logistic regression. Okay, let's look into the regression models that we use in the predictive analytics. Here we have a linear regression model. So linear regression is a baseline modeling, is a simple or straight line modeling technique to model a continuous target variable. There will be continuous variables that is coming for a data. That continuous target variable will be handled by the linear regression. Okay, for example, in a CLV modeling, a modeling technique, a linear regression model can be defined to model the CLV in terms of the recency, frequency and monetary value. So this can be used as the predicators for predicting the values. You can take the CLV as the B0, beta 0 plus beta 1 into R, that is the recency, that is recentness of the value. How recently the data has been collected. Too much old value will not be of any use, isn't it? So we use beta 0 plus beta 1 into recency plus beta 2 into frequency. How frequently you are collecting the data, and the monetary value beta 3 of M. Here the term CLV stands for customer lifetime value. To retain the customer or to predict the outcome of the data related to a customer, how does the customer behave, or how does the customer, what are the range of products, or how does the customer lifetime value changes with the recency, frequency and monetary value can be calculated using this expression of beta 0. Beta 0 are the characteristics that we can use, okay, like age, gender, all those characteristics. They will be multiplied with the recent use of data, frequency of data and the monetary value of the data. All these things will be combined to form a customer lifetime value. Okay, the beta parameters are then typically estimated using the ordinary least squares. You will take least clustered squares to minimize the sum of squared errors. Minimize the sum of squared errors is the unnecessary values will be removed from the least ordinary least squares. Minimum number of squares or minimum size square will be taken so that only wanted data or necessary data will be included in that square. So it is called as the ordinary least square, which minimize the sum of squared errors. As part of the estimation, one then also obtains the standard errors. What are the standard errors that can happen while collecting and making it a regression? Okay, so p values will be used, predicate values for prediction will be indicating variable importance and confidence intervals. At what intervals the data must be collected. You can't collect the data at each and every moment, isn't it? So the time interval or the confidence interval between which, or the time gap between which the data must be collected in a predictive analytics. Okay, what is the advantage of linear regression is? Linear is a straight line regression. We have the diagrammatic representation of this simple linear regression. You can view here the x direction and the y direction. These are the set of values, the past and the present values that are connected through the big data collection techniques, and we'll draw a straight line which covers the minimum values which must be stored for future predication. Okay, so that will be done by the linear regression model. Okay, the key advantage of the linear regression is that it is most simple and works efficiently than any other models. Okay, so this is one of the advantage of the linear regression. Next we shall move on to another type of regression model, that is the logistic regression. What is this logistic regression? What it is going to do? Okay, so when you are creating a response using the linear regression, we get the following expression as y is the set of values. If you take, it will be beta 0 plus beta 1, age plus beta 2 of income plus beta 3 of the gender. We use the characteristics as well as the categories, isn't it? So we use all the values to get the set of values. When estimating this using the least square, ordinary least square technique, two key problems may arise in case of linear regression. What is that? The errors or the target are not normally distributed. There is no normal distribution of the errors or error values or target values. It will follow a Bernoulli distribution. The method of distribution they follow is the Bernoulli distribution, where they take the least values that is possible, which may outburst or which may remove the values that are even critical but are not included because of the OLS, that is the ordinary least square. Some prominent values may also be get out of the square. So that is one of the problem. Another is there is no guarantee that the target is between 0 and 1. Target value is when it is binary, you can't ensure that it is between 0 and 1, which would be handy, which would be much more comfortable because it can be interpreted with a convenient probability algorithm. You can use probability concept to interpret the values, to predict the values. There will be a problem in using the linear regression because it can't confirm you that the values you obtain is only in the binary form. Okay, then what you can do? Consider now the following bounding function. We have f of z equals 1 divided by 1 plus e to the power of minus z. For every possible values of z, if you take the set of values, the outcome will always be between 0 and 1. When you have e to the power of 0 or 1, you always get the value between 0 and 1. So by combining the linear regression with the bounding function, that is between 0 and 1, you have to combine the linear regression model with the combining a bounding function, that is bounding the values between 0 and 1, we get the following logistic model. We use the logistic model here. P is taken as the predictive values. Response equals yes to based on the characters age, income and gender can be calculated like this. 1 by 1 plus e to the power of minus B0 plus B1 age, B2 income plus B3 gender. You have to predict the values or the future of the current values based on this expression in a logistic model or logistic regression model. Okay, the outcome of the above model, the regression model, logistic regression model, is always bounded between 0 and 1, no matter what values of age, maybe 5 or 58 or 96, in spite of any kind of age or income or gender from $1 to $1 million, and gender will always be two binary values 0 or 1. Whatever age you use, the bounding value you get is only between 0 and 1 when you use the expression that I has explained. okay, and can be interpreted as a probability. The chances, probability is nothing but the chances, isn't it? So you can be interpreting the values as a probability. So we have the example classification of the data set with different age group, different income and 2 gender values. So based on the response, you can draw the y value. So if it is response is no, y will be written as 0. If the response is yes, y will be 1. Like this, for no it is 0, for yes it is 1. So logistic regression always handles or always gets the result in a binary value, either 0 or 1, like it takes the response in spite of the different conditions of the age, income or gender. This is one example. In spite of characteristics of the values, it will take only the binary values. Okay. Here we have the bounding function for logistic regression we use. This is the x direction and this is the y direction. You have the set of values which intersect at the 0.5, that is it will always be between 0 and 1. When you use the logistic regression model, you get curve always between the values 0 and 1 in spite of the age or the income or the gender or any value you take. The regression model, the logistic regression model always take the sets of value between 0 and 1. Okay. So the general formulation of the logistic regression model will become P equals y by P of, that is predictive values, y of 1, that is y, if y is set to 1 from the value x1 to xn. So these are the independent variables or the input variables. So the input variables are called as the independent variables. Why they are called as the independent variables is, it doesn't depend on other variables, isn't it? Or the result of any expression. It is directly given without any dependency. So it is called as the independent variable, whereas the output variables will be considered as the dependent variables. Why? Because they depend on the input variables as well as the expression, isn't it? So output what we obtain is not independent. It depends on the input what you have given. If 2 plus 2 is given, the result will become 4, isn't it? 2 and 2 are independent variables. They don't depend on anybody, isn't it? But the result 4 depends on the input variables 2 and 2 and the operator that we have given. If it is 2, 3, if you use the plus operator, the output will become 5. If you use multiplication operator, then the result will become 6. That means the output variable always depends on the input variables, isn't it? So it is called as the dependent type of variable, and the input variables are generally considered as the independent type of variables. You can take the independent variables to check the y value based on the expression 1 by 1 plus e to the power of b0 plus b1x into x1 up to bn up to xn. You can take, or alternatively, if it is y is set to 0, you can take the input variables x1 to xn with same expression 1 minus p of y of 1 into x1 to xn. So you can substitute the expression and get the final expression. Okay. You can get the final expression in a logistic regression. Okay. So both p of y equals 0 and 1 minus p y of 0 are bounded between 0 and 1. You can observe from the expression as well as the graph diagram. You can observe that the y value always ranges from only 0 to 1. Okay, reformulating in terms of odds, not the goods, in terms of odds, the model will become P is y equals 1 of x1 to xn and y equals 0, x1 to xn, that is equal to, only expression is taken when you remove the numerator and denominator, remains is E equals beta of 0 plus beta of 1 into x1 plus beta 2 into x2 up to beta n into xn. So we take all the set of values between 0 and 1. Okay, or in terms of logarithmic representation of odds, we take log n of p of y equals 1 or x of 1 on the variables x1 to xn. Again, p predicate values from y equals 0, that is x1 to xn, will take the following form. So we have the decision boundary of logistic regression, where we use the income and the age. So we consider the age and the decision boundary of logistic regression. Decision boundary will take the G and goods and bads. According to that, it will be taken. So age and income. As the income increases, age also increases. The good characteristics will increase, whereas the bad will become minimum. Whereas the decision boundary says the set of values, both bads will be more when age is less and income goes on increasing. When age increases, then only good characters will increase. This is a prediction. It is not the exact value we get. It is the prediction of the future by using the current data based on a apartment or based in a residential society. We have so many persons. Some are employed, some are business, some are unemployed. So we have all sorts of people. And people with all age groups and both the genders, male and female. In such a case, how does the good and bad characteristics will increase and decrease, or the purchasing power of the group in a society that we can take? Purchase power will increase with the increase in income, but the purchasing will may be reduced with the age. So this is another example you can take. Here it is taking only the bad and the good characteristics. What the predictive analytics says is that bad will be more when you have increasing income and increasing age. So you'll have bad characteristics more in this regression boundary, whereas when the age increases after certain level, the goods will become more. So predictive is good is more than the bad. Okay, this is a regression expression you can take. The beta I, that is the categories, different categories, parameters of a logistic regression. The categories of logistic regression model are then estimated. How do you estimate what are the categories? Is by optimizing a maximum likelihood function. Similar kinds of functions will be clustered or optimized to get the categories of parameters. Categories as parameters. Just as with the linear regression, the optimization comes with the standard errors. There will be errors because it is prediction. It is not exactly what has happened. It is the prediction of the future. There will be standard errors that can happen. Predictability values that you can take for variable screening and confidence intervals. At what intervals the data must be collected will be specified by using the logistic regression. Okay. The optimization will be done in the logistic regression to get the time interval as the set of values. Okay. To interpret a logistic expression or regression model, one can calculate the ratio of odds or the characters or the prediction which does not belong to any category. We do the categorization. If any of the data, none of the data or some data, if not categorized into a particular category or classification, you have to interpret the logistic regression model. You can use the ratio of odd. What happens? Suppose variable xi is the input variable, increases with 1 unit. You will increase with or increment with 1 unit with all the other variables being kept constant. Other values are kept constant. Only one xi will increase with 1 unit, that is. Okay. Then the new logical value becomes the old logical value with bi added. You are going to add the category, one more category with keeping only one value for variable and others as constant. Okay. To interpret a logistic regression model, we use the bi value. Hence, the bi, if it is greater than 0, implies the empirical value of bi is greater than 1. The empirical value will be greater than 1 and the odds and probability increases by xi. Okay, if you take I value, the probability will increase by xi. If the bi is less than 0, what it becomes? It implies the empirical value of bi will be less than 1 and the odds and probability decrease with xi. So, it will be in negative quadrant. So, the xi value probability will decrease, whereas when bi is greater than 0, the probability will increase by xi. So, we have two conditions when bi is less than 0 and bi is greater than 0. Okay. Another way of interpreting a logistic regression model is by calculating the doubling amount. So, predicting the doubling amount. This represents the amount of change required for doubling the primary outcome odds. So, it has to calculate the doubling amount. Okay. So, the doubling amount represents the amount of change, how much change may be done in the future. There may be, since it is a predictive one, you can't exactly say whether the values will be doubled or it will increase by what we have predicted in our expression. So, we have to use the doubling amount to exactly predict or exactly check the or interpret the value that is obtained by the logical regression or logistic regression model. Okay. Note that along with that, next to the FZ transformation, which was already discussed, other transformations have been suggested in the literature. We have so many other transformation methods apart from f of z, which gives you another set of values. Okay. Popular examples are probit and double logarithmic transformation we can use. So, this is the expression which you can use to probabilistic algorithm or probabilistic calculation and double log transformation. Okay, probabilistic transformation and double log transformation will be used to predicate or to transform the mere set of values to a predicate value. Okay. The probit transformation was used in the one of the tool, that is Moody's Risk Calcs tool, for predicting the probability of default for firms. So, it has to use the probability of the values for different firms or the organizations. Okay. However, the empirical evidence, the e to the power of minus z evidence, suggests that all three transformations will typically perform equally well. The performance of the transformation techniques that we use in the logistic regression will always work in a better way. This is about the predictive analytics. One of the technique of predictive analytics, that is regression model. Regression model is nothing but the technique for predicting the future value by using the current as well as the historical data. Apart from this, we have two more techniques in predictive analytics, that is the decision trees and the neural networks, that we will discuss in the next session. Thank you.